In this final video for binomial distributions, we're going to look at the probability model. The probability model is going to be a formula that we can use to calculate probabilities. But first we're going to look at some symbols and what they mean, and some of these you will be familiar with if you watch the first couple of videos. In a binomial experiment, the random variable is x equals the number of successes. The values of the random variable are 0, 1, 2, etc. up till n, where n is the number of trials. Lowercase p denotes the probability of success. And we've seen these before, but there's one more that's new, and that's little q. And this is the complementary probability, so it's the probability of failure. And of course, if you know the probability of success, then 1 minus that quantity will give you q. Okay, so these are the symbols that are going to go into my formula. And the formula for the binomial distribution, or the probability model, is p of x equals n choose x, p to the x, q to the power of n minus x. And I know this might seem a little intimidating, but it's not. I'm going to show you how to plug in the numbers in the right places, and this is one way to calculate probabilities. Now this thing in parentheses, n choose x, is actually a so-called a binomial coefficient, and you can calculate it using factorials. Okay, let's jump to an example. Now this is the same example we saw in the previous video, and we looked at simulations to answer some probability questions. So toss 5 coins and record the result. We are interested in the number of heads. So the random variable is the number of successes, which in this case is the number of heads. We have 5 trials, and because this is a fair coin, the probability of success is 0.5. So if we take that formula we just saw and we plug in these parameters, we replace n with 5, we replace p with 0.5, and q is 1 minus p, which is also 0.5. So this is called the probability model. This gives us the probability of x successes. And x, of course, can range from 0 through 5. So for example, if I want to use this formula to calculate the probability of exactly 3 successes, which in this case, in this context would mean probability of getting exactly 3 heads, then I would just plug in 3 instead of little x in that formula, just like this. And once I calculate this, that would give me the answer. Okay? Now, what we're going to do is we're going to answer some probability questions. These are exactly the same questions as we did before, but this time we're going to use the probability model. And instead of using the formula, we're just going to jump to this Stats Lab app, tap on probability distributions, go to the binomial distribution, and well, we got to change a couple of things here. First, we're going to change the parameters. The n should be 5. P, which is probability of success, should be 0.5. And then I'm going to just swipe over here to reveal this table. And this is the table we're going to use to answer these questions. The first question is, what is the probability of getting exactly 3 heads? And if you look at this table under 3 for x, the is 0.3125, or about 31.25%. For the next question, it says, what is the probability of getting less than 4 heads? Okay, so that means up to 3. So for that, we could actually use this diagram here. Instead of 7 for the successes, I'm going to put 3. And make sure the left tail is selected. So what this is here, the right tail gives us three or more, and the left tail gives us 3 or less, and that's what we want. And it looks like here the probability of getting less than 4, which is up to 3, is 0.8125, or 81.25%. Now in this example, again, we've seen this in the previous videos, but we're going to look at it again. Choose 5 marbles, one after the other, and with replacement, from a box containing 6 red and 4 green marbles. We're interested in the number of red marbles. So a random variable is the number of successes, and we're going to say that getting a red marble is a success. So x is the number of reds, number of trials is 5, and the probability of success is always 0.6 because we have 6 red and 10 total, so 6 out of 10 is 6/10. Okay, so now if I write the probability model, I'm going to replace n with 5, p with 0.6, and q is 1 minus 0.6, so it's the probability of failure, which is 0.4. So I already used this formula to calculate, for example, the probability of exactly 2 successes. Then I would just take that and replace little x with 2. And then once I evaluate that, then that'll give me the answer for the probability of 2 successes, which in this context means the probability of 2 reds. Okay, so now we're going to the StatsLab app and we're going to use that to answer these questions. So I'm here in binomial distribution, but I want to change one of these parameters. So the number of trials is 5, that's good, but the probability of success now is 0.6. Okay, if I swipe over here, I'm going to see that the probability of exactly 3 reds, which is x in this case, is 0.3456 or 34.56%. And to answer the other problem, the probability of getting less than 3 reds, well, less than 3 means up to 2. So going back here, I'm going to tap here for x successes in type 2 and make sure the left tail is selected. That means up to 2. Right tail gives me 2 or more, left tail gives me 2 or less, and that's what I want. It looks like it's about 0.3174 or 31.74%.